Lakini ukasaidika?
Imekaa tu hivyo sasa hata sina.
Ndio unateresia kwa ndani mbaya. Ile ndio maana pale. Ndio baada ya PSG pale. Ana wale mwesi alikuwa na shida hii.
Au hii mwalimu nilisikia wanaomba bibi.
Akijia jina. Basi kama walifanya introduction first class. Nilikuwa nasikia tunaongea kama assume hizo notes za ama kuna notes za
WhatsApp kwamba akiona notes zilikuwa kwa screen.
Hapana zilikuwa kwa kitu.
Zilikuwa kwa screen.
Walafu unanidi alikuwa na sasa yaona.
Sasa ukiwa online aweke hapo kwa screen hata unaona.
Sasa televisheni kuna anaangalia televisheni asifuatilie hizo sana.
Lazima ujue jina yake obviously kwa hapo. Simu login na majina mengi.
Basi niliona si kabaya mtu. Sasa anakaa kwa explain sana.
Ndio ushike. Ndio ndio ile information ukiwa kwa kitu.
Explain.
Sasa kumbuka kitu alisema kwa kitabu. Hizi ya
Hadi kuna ile usingizi badikana kika. Iko mchezo. Zile zilizopiga picha. Kuna andika kwa ngome.
Sasa kama jana niliandika na kitabu.
Ajana sinisikia kusoma
Panzen.
Okay, so we just pick up from where we have stopped. Teresa, how are you? Where did we stop exactly? So we stopped at scatter diagram. So We now proceed to discuss the next method called industrial engineering methods. Industrial engineering methods. Industrial engineering methods. And we write that this is where a professional engineer, this is where a professional engineer applies professional knowledge. A professional engineer applies professional knowledge, skills and experience, to express the relationship, between inputs and outputs, in physical quantities. The physical quantities are then expressed. In terms of money, to determine the costs, of the outputs, determine the costs of the outputs. So that is all about industrial engineering. It is nothing much. And what we have said is where a professional engineer expresses the relationship between the inputs and outputs in physical quantities. If you interact with the engineers, you hear the word BQ, bill of quantities. When you want to build a house, the engineer will tell you how many bags of cement, how many metal rods, how many tons of sand, stones, and so on. Then when you are given that bill of quantities, you go now and estimate the price, and you know the house that you want to build will cost you how much. That one is as simple as that. The next method that we are supposed to mention, is called account analysis. Accounts analysis method. Accounts analysis method. Accounts analysis method. Right, that this method involves classification. This method involves classification of costs into fixed and variable components. Into fixed and variable components. First of all, an equation of the form y is equals to a plus bx. An equation of the form y is equals to a plus bx is then developed. So example one. Example one. The following information was obtained after producing 40 units in a certain company. 40 units in a certain company. So we have direct materials costs. Direct materials costs. 80,000. Indirect materials costs. 60,000. Direct labor costs. 100,000. Indirect labor costs. 30,000. Depreciation. 20,000. Repairs, which are 20% direct. 40,000. Electricity, 5,000 fixed. 21,000. Utilities, 40% indirect. 40% indirect. 40,000. Support costs, 8,000 variable. Total is 15,000. Required. 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 Predict. predict the cost of producing 28 units. Predict the cost of producing 28 units. The cost of producing 28 units. So pick a solution. Now, in the solution, we are going to have analysis table. We draw analysis table. And this analysis table has 3 columns. The first column is where we have the cost item. Cost item. The second column is where we have the variable. Variable costs. And the second column is where we have the fixed. So just a minute, you see what you're supposed to do. We know that direct materials is a fixed or variable cost. Look at the notes I gave you the other day about direct costs. Are they fixed or variable? Direct costs. They are variable, and indirect costs are fixed. So this is what you're going to do. For the direct material, it is variable. Indirect material, it is fixed. So this one now should be put in the column of the fixed here, 60,000. The same case with direct labor, that is variable to be there. Indirect labor is fixed. So this one comes here. This one comes here. And then depreciation, is it a fixed cost or variable cost? Fixed. Depreciation is a fixed cost. So that one should be classified here. Then this one, chukua calculator will patia 20% of 40,000. 20% of 40,000 is 8. So 8 is the variable. So that means to make sure that 2 being what? Fixed. And then for the electricity, 5,000 is fixed. So the variable one then must be 16. So that when you add the 5,000 that is fixed, you go back to 21. Then for utilities, give me 60%. That is variable. 60% of 40,000. 60% of 40,000 is 24. So that means the fixed one is what? Yeah, 16. And then for the support cost, 8,000 is variable. So we have 8,000. So that means the fixed one must be what? Yeah, it is as simple as that. You just look at the cost items, put the ones that are variable together, the ones that are fixed. So quickly get to that point. so that we pick up from there. We get the totals. Give me the total variable you have gotten. 236,000. And fixed you have gotten 170,000. So now below that, B, which we say is the variable cost per unit, should be 236,000. You divide by 40. That is shillings how much? Hmm? 800. 5,900. And then we know A, which is the fixed cost, is shillings 170,000. We agree with that? Okay. So then you tell us thus Y is equal to 170,000 plus 5,900 x 5,900 x. So when x is, we wanted to predict for 28 units. So when x is 28, then y will be 170,000 plus 5,900 times 28. That gives us a total of how much? Three that 5,200. 335,200. So that is how you deal with account analysis, and I'm not going to give you any other example because the concept is already well illustrated, that it is simply about judging whether the cost is variable or fixed. Let's go to the next method. The next method, which is called high-rule method. High-rule method. High-rule method. High-rule method. And write that this involves identification. This involves identification and selection. Identification and selection of the highest of the highest and the lowest values of x and the lowest values of x together with the values of y. Together with their values of y. An equation of the form y is equals to a plus bx is then developed. So we have this question that was tested in sometimes in June 2003. So June 2003, question 4. It is not in your past papers, so I will read as you write. And I will not read everything, just make it very brief. Consider the following data. We have the month here. The month is January, followed by February, followed by March, and then April, then machine hours. Machine hours in January, there were 800. In February, 1200. In March, 400. And in April, 1600. Maintenance costs in thousands, shillings in thousands. We have 350 here. We have 350 also. We have 150. And we have 550. Required is determine the cost estimation function. Determine the cost estimation function using semicolon and Roman 1 high rule method. That was given 5 marks. And Roman 2 regression analysis, which had also 5 marks. Also. So in the solution, Obviously, you must know where you are going before you start the journey. And where we are going is a place where we will have an equation of the form y is equals to a plus b x. Of the form y is equals to a plus bx. And then we have said when you are in the high row, what you do, you go to the column of x. So the question has not told us who is x, so it's upon you to know. So who is our x here? Huh? The machine hours. X is the one that makes the other one to change. So it is the machine hours that should be changing what? Maintenance cost, but not maintenance cost making machine hours to change. Yeah. So X is the one that makes the other one to change. So X will be machine hours. So tumesema, what you do, you go to the values of X and you pick the highest and the lowest. So what is the highest here? 1600, and the lowest? The lowest is 400. So you identify those points. Once you identify them, you select them together with their values of 1. The values of 1. And although here you can see this happens to be the highest and this to be the lowest, that's not the case. Or it's not always the case. By that I mean, we do not come to I to select. You only select in X. Chenye umepata kwa X, it is the one that guides you what to take in Y. So having done that, then for the highest, the cost is 550. Now, if you write something like this, 550, and then you proceed, your answer will be wrong. Your answer will be wrong. Why? You can see these ones are in thousands, and these ones are not in thousands. When you're developing an equation, you must ensure that data is of the same form. Data is of the same form. Either urudishe hizi zero hapa, ama urudi hapa, vile vile umoe zeros. But the data should be the same form. So the easier that I want us to do for this one is to rudisha hizo zeros, so that you work with 550,000 being equal to A plus 1600 B, and this is because of the highest. That is because of the highest. Because of the highest. All right. Then we go to the lowest. The cost is 150,000. So this is A plus 400B. This is the lowest. So then you immediately start on solving. Obviously, you subtract. You subtract that. When you subtract 550 minus 150, we get what? We get 400,000. Being equal to this other one is what? 1200 B. And based on that, tell me B is what? That's 3. Now, what does this mean? This 3 meaning. Look at where we began the topic. I gave you the meanings of these items. I told you Y represents what? Y represents total cost. A represents B and X, the activity level. Now that one is a general case, but when you are dealing with a question, it becomes specific. So you will not only say that Y is the total cost, but it is the total maintenance. So that unajua ni nani tunadili na yeye. So it's the total maintenance cost. So you don't just tell us it's total cost. So equally, this one now we need to describe it. So utasema it is maintenance costs per machine hour. It is the maintenance cost per machine hour. That is the maintenance cost per machine hour. So in other words, that is also the variable cost per machine hour. So let's proceed. Kuja hapa useme 550,000 is equals to A plus 1600 times 333.3. So give me A. Based on that, give me $16,000. So we can make it 667. Okay. And then you tell us this is the fixed maintenance cost. That is fixed maintenance cost. Thus, Y is 16,667 plus 3333.3 X. Okay. The next one is a question that was tested also sometimes in June 2010. So I think June 2010. June 2010, question 3B. June 2010, question 3B. Right, that the following information was obtained from the budget. The following information was obtained from the budget of a company. From the budget of the company. So we have the year there, then followed by sales units. So sales units were 150,000, 180,000, 200,000, and 230,000. It is followed by sales revenue. Sales revenue. Then we also have variable costs. Variable costs. Then we may require, in the solution, you require another column, although it's not given here. So that space kidogo hapo. So the sales revenue is 294,820, 346,706, 363,000, and 448,800. Then this is 132,820. 162,706, 179,000, then 200, 800. Okay, then down they write that sales for the year 2011. Sales for the year 2011 have been estimated at 260,000 units. Sales for the year 2011 have been estimated at 260,000 units. 260,000 units required. Estimate the contribution. Estimate the contribution for the year 2011. For the year 2011, using Roman 1 IRU methods and Roman 2 regression analysis. Regression analysis. So that one you shall do on your own, but maybe I can help you jumpstart by two things. What will be your X in this data? Your X itakuwa nani? Yeah, sales units. And who will be your Y? Who will be your Y? Sales revenue. Okay, now before you write that, go to where I gave you the steps of estimating cost functions. I gave you some steps of estimating cost functions. Are you there? The first one, what did it say? You identify the dependent variable. Then this.
This is the variable whose values have been
It is the variable whose values are being predicted. That's all. Then in this question, we are told to predict who? Is that what the question says in the required? We are told to predict. To predict what? Profit or contribution. In the words of the question, it is contribution. Yes. So that is how you know who is your Y again. So it is the contribution. So how do we get the contribution now that it's not given here? How do you get contribution? It will be it will be revenue minus variable cost. It will be revenue minus variable cost. So that means you will require another column here or working down there where you get the contribution. You ukishajua the highest units and the lowest, you take their contribution, form the equation. So here utafanyia nyumbani. Leave a space of like 5-7 lines. Leave a space of like 5-7 lines using the high-low method. And let's now discuss regression analysis methods. That's the next method. Regression analysis methods. Regression analysis methods. Regression analysis methods, and you write that this is a statistical method. This is a statistical method. I've said the column should be for the contribution. Borrow, that's what I've said. Contribution. So we proceed and say that this is a statistical method used to study the nature and the strength of the relationship, the nature and the strength of the relationship existing between variables. First of all, if only one independent variable exists, if only one independent variable exists, if only one independent variable exists, the data is called univariate. The data is called univariate. The data is called univariate. And the analysis is called simple stroke least squares stroke ordinary least squares method or analysis. So it has 3 names. And the analysis is called simple, just call it simple analysis. You can also call it least squares. Least squares. You can also call it ordinary least squares. First of all. Then down there you write that the general format of a least squares function, the general format of a least squares function, the general format of a least squares function is y is equals to a plus bx, is y is equals to a plus bx, where b is equal to n sum of xy minus sum of x sum of y you divide by n sum of x squared minus sum of x, you square and a is sum of y minus b sum of x, you divide by n. Divide by n. Then down there you write that if more than one independent variables exist, if more than one independent variables exist, the data is called multivariate. The data is called multivariate. The data is called multivariate. And the analysis is called multiple. And the analysis is called multiple. Analysis is called multiple. Then below that you write that the general format of a multiple regression function, the general format of a multiple regression function, the general format of a multiple regression function is y is equals to a plus b1 x1 plus b2 x2 plus all the way back up bn xn. The general format of a multiple regression function inakuwaga namna hiyo, where n is number of independent variables. The number of independent variables. Number of independent variables. down there you write that the nature stroke type, the nature stroke type of the relationship is represented by the sign of the slope, in brackets B, the sign of the slope, brackets B, and correlation coefficient, into brackets R, brackets R, where if you are told to compute R between X and Y, R between X and Y, R between X and Y, where R between X and Y is given as N sum of XY minus sum of X, sum of Y, sum of X, sum of Y. You divide by N sum of X squared minus sum of X. You square this, then you multiply by N sum of Y squared minus sum of 1 which is squared. That is how you compute R between X and Y. Okay, then from there, you put something like this. R is supposed to be between -1 and +1. The lowest you can get is -1 and the highest is +1. Then down there, you write that there are 3 types of relationships. There are 3 types of relationships. 3 types of relationships. One is called direct relationship. Direct relationship. direct relationship, and we write that this is where the variables change. This is where the variables change towards the same direction. Variables change towards the same direction. First of all, it is represented by a positive value. Is represented by a positive value. Number two, inverse relationship. Inverse relationship. This is where the variables change. Is where the variables change. This is where the variables change towards opposite directions. The variables change towards opposite directions. It is represented by a negative sign. Represented by a negative sign. Number three, null relationship. Null relationship. And you write that this is where a change in one variable, does not affect the other variable. Does not affect the other variable. It is represented by a zero value. It is represented by a zero value. Then down there now you write that the strength of the relationship, is represented by the absolute value. Is represented by the absolute value. Absolute value of the correlation coefficients. Absolute value of the correlation coefficients. In that The closer to 1 the value is, in that the closer to 1 the value is, the stronger the relationship. The stronger the relationship. E.g., G minus 0.9 minus 0.9 represents a stronger relationship. Represents a stronger relationship than 0.7. Than 0.7. Yeah, so I think what I have said there is well understood, and also bearing in mind this is not the first time you are hearing about regression. You have been talking about it right from section 2, section 4, so this is that time. So the only thing that maybe I may need to emphasize now is what I've said here, that the closer it is, the stronger the relationship. When you see the word absolute, it means you ignore the negative sign. It means you ignore or you drop the negative sign. So if you drop this one, then you realize 0.9 is closer to 1 than 0.7. That's the only point that I needed to emphasize. So let us solve this question, June 2003, question 4, using regression. Let us solve that question. So when you are solving regression, so we are solving the question of June 2003, question 4. So what we are preparing now is called the analysis table. Now the analysis table, as far as simple regression is concerned, usually has 4 columns. It has a column of X, it has a column of Y, it has a column of X multiplied by Y, and a column of X squared. So we normally have those 4 columns. We have those 4 columns. So that is our analysis table. So look here. I told you earlier, when you are given data that is not in the same form, you must convert it to be the same form. And I told you, you either add the zeros back here, when we were high row, what we did to reduce the zeros. But also in the regression, because of this square, it's not going to be big. I thought this one to be when we square this y, but I think it's okay. So Ukiona, if you work with full figure, it will give you very high values. It's better. But other you work with 350,000, you work with 350. Also, you make it 0.8. Yeah. But ensure data is in the same form. So hapa tuko na 800 Then we have 1200, we have 400, and we have 1600. Then this is 350,000. This is also 350,000. This is 150,000. And this is 550,000. Then you take your calc and start the workings, where you say 800 plus 1200 plus 400 plus 1600 is 4,000. 350 plus 350 plus 150 plus 550 is 1,400,000. 800 times 350,000 is 280 million. 1,200 times 350,000 is 420 million. 400 times 150,000 is 60 million. 1,600 times 550 is 880 millions. So 880 plus 60 plus 420 plus 280 is 1,640,000,000. 640. Then 800 square is 640,000. 1,200 squared is 1,440. 400 square is 160,000. 1,600 square is 2,560,000. So 640 plus 1,440 plus 160 plus 2,560 is 4,800,000. So I know we are familiar with those procedures. That's why I'm moving faster. So ukishapata those values, you now proceed and get B. And because you already have the formula slightly up there, I'm just going to substitute. I'm not going to repeat the formula. The formula requires we get N. N is 1, 2, 3, 4. So it is 4 times the sum of XY. Sum of XY is 1,640,000 minus sum of X. Sum of X is 4,000 times sum of Y, which is 1,400,000. So sasa hii unagawa namna hii. Divide that way so that you tell us N, which is 4 multiplied by sum of X squared. Sum of X squared is 4,800,000 minus sum of X squared, 4,000 times 4,000. 4,000 times 4,000. So if I say 4 times 4, 8 exponential 5 minus 4,000 squared equals. So the universe multiplied by 4 times 164 on 70, so exponential 7 minus 4,000 times 14 exponential 5. Close the brackets equals. What is the answer? What is the answer? Okay, next time come with it. Those who are online, what is the answer? Teresia and Mine, I need your answers. It's an early morning class where we are very fresh. What do you have? You know, I'm getting 300. Good. So with 300, we proceed to get the value of A. A will be sum of Y. Sum of Y is 1,400,000 minus 300 times sum of X, which is 4,000, which is 4,000. You divide by N, which is 4. And the interpretations remain. Venye tu tulisema hapa, this 300 is the variable cost per machine hour. So it still remains, just like we said, venye hatujaandika kwa hii. So sasa hii itakuwa times 4,000 equals. So 1,400,000 minus the answer divided by 4. Tell me what you're getting. $50,000. $50,000. Thus, Y is equals to 50,000 plus 300x. Y is equals to something like that. So what you should be able to see clearly is that different methods will give you different results. Now ile hairo iko imetupea 3 na hapa wakatupea 16. But this one now is giving different results. So I want you to leave a space equal to what this one has taken, where you shall use to, or which you shall use to solve June 2010 question 3B. June 2010 question 3B. And after you do that, you can also check. You can also check. Let me see a password. November 2017, question 2B. November 2017, question 2B. Good. Now from there, we now discuss something called testing reliability of the equation. Testing reliability of the equation. Testing reliability of the equation. Tumesema the question of November 2017, November 2017, question 2B. So make sure you check on that. I hope, Boro, you have gotten that. I think that's a question I solved in class last semester, and then I'm told it was in the exam. I hope they did well. I've not seen the paper. I'll check. Okay, testing reliability of the equation, and write that these are tests undertaken. These are tests undertaken These are tests undertaken to judge the accuracy of the equation, before adopting the equation as a general forecasting tool. Before adopting the equation as a general forecasting tool. General forecasting tool. The tests are divided. The tests are divided into three areas. The tests are divided into three areas. As follows. Three areas as follows. One, economic plausibility. Number two, goodness of faith tests. And 3 is assumptions. Assumptions. Okay, so I want us to have an illustration. So the table will have 10 columns. So illustration, analysis sheet, and this question was tested in December 2007 as question 1C. We have labor hours, which will be our X, obviously. We have repair costs, which will be our Y. Our Y. Then, just like we have done with the other one, we will require a column where X is multiplied by Y. We will also require a column where X has been squared. That will help us get the equation. Then we have the forecasts. The forecast is normally called Y predicted. Then we have the error, which is given as E is equals to Y minus Y predicted. Y minus Y predicted. Then we have a column Y minus Y predicted, which is squared. Then we have Y predicted minus Y bar, and then you square that. Then you have Y minus Y bar, you square this. Then you have X minus X bar. So that is the design of the table. We have 4, 5, 3, 6, 4, 2. This is 600, 800, 550, 1,700, and 500. So below that, and maybe because you people, you know how to use the calculator, and even if you don't, I'll just show you the results. So we normally say shift regression linear. So it is 4,600 m plus 5,800 m plus 3,550 m plus 6, 1,000 m plus 4, 700 m plus 2, 500 m plus. So shift x square. If you come to x square, is giving me 106. That is the total. Sum of x is 24. If you don't know how to use the calc, just follow the normal procedure and it will be acquired in there to get those totals. 17,850. So now, A, the value of A from my calc, I'm getting 191.67, and the value of B I'm getting 125. So just copy these results. If you want to verify, utafuata ile normal procedure ya regression ile tumetumia kwa hiyo swali lingine. Haya, then kuna kitu kingine huwa tunaita x bar. Maybe x bar is the mean. So if 24 you divide by, these values are 1, 2, 3, 4, 5, 6. So if you divide by 6, that will give you 4. And then y bar is 4150. You divide by 6. I'm getting 691.67. 691.67. Y will then be equal to 191.67 plus 125x. Get to that point. Sorry, time with the Peter. Dahil, your class has not yet come, so log out. So now what we shall do to get this column, to get this column, maybe we can have one working. Y predicted, utakuwa unachukua this equation 191.67 plus 125 times the value of x. The value of x is 4. So you can write that one there. So it is 191.67 plus 125 times 4, and the answer is 691.67. So that is the one you shall write here, 691.67. 691.67. Then the other one, y predicted, will be 191.67 plus 125 times 5. So 191.67 plus 125 times 5, I'm getting 816.67. So 816.67. So we may know how to do this then. Okay, then for this one, see the formula is clear. It is y minus y predicted. Let's do one. The same as 600 minus 691.67. And I'm getting minus 91.67. Then you square that value to write it in the next column. When you square, it will be 8403.3889. 8403.3889. Huyu mwingine y predicted minus y bar. So utachukua hii predicted, tuseme 691.67 minus y bar. What is our y bar? Ndio hii. Zinatoshana, eh? So that one now becomes what? A 0. That becomes a 0. Haya. Huyu mwingine y minus y bar. Chukua this value of y, 600, minus y bar. Y bar is 691.67. Square that value. Square that value. You get again 8403.3889. And then x minus x bar. So chukua this 4 minus 4, that gives us what? Another 0, eh? That gives us a 0. So have you understood everything? Okay. So I would want you by the time we meet tomorrow. Remember we said we're meeting tomorrow from 6:30 to 10. 6:30 to 10. So by the time we meet tomorrow, uko umejaza mpaka totals. because that is what now we shall discuss. Tomorrow from 8:30, no, not 8:30, from 6:30 to 10. So when you come for the physical class, we will be in the other room. We will not use this room, the core section. Yeah. So let's call it at the other juncture and pick up from there.